All right, today we're going to talk about 9.2, which is all about graphing our polar functions. So we're going to start with some easy ones here. So the first one that we have is r equals -3. So when we have r equals -3, okay, that's saying that the radius is -3 for any theta, right? Theta could be 15, theta could be 77, theta could be 120. It doesn't matter what theta is, the r is always -3. So this is a circle with center 0, 0 and a radius of 3. It doesn't really matter that it's negative, right? Because if I was at 60 and I went -3, I would get to 240. If I was at 240 and I went -3, then I'm back at 60. So it's just going to be a circle at the center of 0, 0 with a radius of 3. Okay. So that means my intercepts would be 3, 0, -3, 0, 0, 3, and 0, -3, right? Those would be our intercepts. Next we have theta equals 5 pi over 6. So this is saying no matter what the r is, our theta is always 5 pi over 6. So this is going to be a line through 5 pi over 6, which is 150 degrees. So this is going to be all of these. Remember, we also have to go into this 330 region, because if theta was 5 pi over 6 but r was negative, I would be at 330, right? So this is for all r's, positive and negative. Okay, don't forget our arrows. Our only intercept here would be at 0, 0. Okay, moving on to 3 and 4. So in number 3, I have r sine theta equals 2. Okay, well we know that r sine is the same thing as y. So this is the same thing as y equals 2, which if you remember back to algebra, that's a horizontal line at y equals 2. So we go to where y is 2, which would be right here, and we're going to create a horizontal line. So the only intercept we have on this line here is 0, 2. Okay, with number 4, r cosine is the same thing as x. So we have x equals -4. So this is going to be a vertical line at x of -4. So we're going to go where x is -4, should be right here. And we're going to make a vertical line. So our only intercept that we have there is -4, 0. Moving on to some more interesting ones. So on number 5, we have r equals 16 sine. So on the last problem we had r sine equals 16. So this is different. This is saying r equals. So I can't replace anything with y. So when we have one that looks like this, we've got r equals a number and then sine. This is going to be a circle with a diameter of 16. Okay, which means our radius would be 8. The sign tells us that it's going to be opening up or down. The 16 is positive, which tells us it's going to be up because it's positive. Okay, so we're going to start at 0, 0. Our radius is 8. And the diameter is 16. So I'm going to ignore that these have the units there, otherwise we won't be able to fit it. So let's make these go by 2. So we've got 2, 4, 6, 8, 2, 4, 6, 8. And then we want our radius this way and this way to be approximately the same, so I kind of just eyed this distance and made it the same this way. And then we're going to try our best to make a circle. Even my circle is kind of funky looking, but just try your best. I don't need it to be perfect, but try your best to make this into a circle. Okay, number 6, we have r equals -6 cosine theta. So because it looks like this, it's a circle with diameter of 6, which means our radius is 3. Sorry, over here I forgot to say. So that would make the center be at 0, 8 with a radius of 8. Okay, so our radius is 3. We need to figure out what the center is. Because it's cosine and it's a negative, cosine tells us it's going to open left or right. Because it's negative, it's going to be opening to the left. So we're going to start at 0, 0. It's going to open to the left 3. So 1, 2, 3. 1, 2, 3. So that would make the center at -3, 0. And then we're going to eye that same distance here and create a circle. All right, number 7 and 8. So number 7 and 8, we have 5 plus 5 sine and -4 minus 4 cosine. So because these are the same numbers, these are going to be what's called a cardioid. Okay, cardioids kind of look like a heart. When we have a cardioid, we want to figure out what is A and B. So in this case, A is 5 and B is 5. A always tells us where our intercepts are. So these are going to be where our intercepts are. A plus B gives us 10, which is going to tell us where our other intercept is. So because this is a sine and these are positive, it's going to be opening up because these are positive and it's a sine. So we're going to start at 0, 0. It's going to be opening up to 10. So I'm going to have to go all the way up to 10. Let's say that's about here if I followed these. And then our intercepts are going to be along our x-axis because it's opening up. So I'm going to go out to 5 for each of those. And then we're going to connect. This one goes down, kind of like a heart. And then try our best to make this look circle-like. That's a cardioid. So our intercepts here are -5, 0, 5, 0, 0, 0, and then also 0, 10. My camera keeps freezing. I apologize. Okay, here they are. Number 8, we know A is 4 and B is 4. So when we add those, we get 8. Because they're negative and it's a cosine, we're going to be opening left. So these are going to tell us our intercepts. This is going to be how far we're going out. So we're going to go to the left 8 units, which would be at the end here. 0, 0 is our start. And then that would mean our intercepts are this way. So we're going to go out 4 units this way, because this was a 4. And then we're going to connect and make our heart. Try our best to make this circle-esque. And we have our cardioid. So our intercepts would be -8, 0, 0, 0, 0, 4, and 0, -4. Okay, so moving on. So 9 and 10, now we have different numbers here. We've got 4 and 5 and -2 and 6. So when we have different numbers, this is going to be what we call, and I could be pronouncing this wrong, but limation. Okay, these are the ones that have the loops in the center depending on what our A and our B is. Okay, so in this case, A is 4 and B is 5. So A plus B is going to give us 9. And then we always do B minus A, not A minus B, but B minus A. So B minus A would give us 1. Okay, so what does that mean? Well, because it's a sign and it's positive, it's going to be opening up. So I'm going to go 9 units up, should be about here. Okay, A tells us our intercepts, just like in our cardioid. So because A is 4, I'm going to go out 4 here and here. That's 0. But we're not going to make this into a cardioid because these are different numbers. What happens is that we have what's called a loop that has a length of 1. So our loop has a length of 1. So we've got a little loop here. And then we make it into a cardioid, essentially, the same type of drawing as a cardioid from there. So we've got a little loop, and then it comes around, a little loop, and it comes around. In number 10, we've got -2 plus cosine of theta. So A is 2, B is 6. Notice I always just do the absolute value. I ignore that that is negative. So A is 2, B is 6. So because we have A is 2 and B is 6, A plus B is going to give us 8. B minus A is going to give us 4. Okay, so because this is a cosine, it's going to be opening left or right. Now, it doesn't matter that this -2 is in the front. Okay, what matters is this sign is positive or negative. So because this sign is positive, this is actually going to be opening to the right. So we're at 0, 0. Our loop length is 4. Our total length is 8. So our loop here is going to be 4. We have intercepts at 2. And then the total length is 8. I forgot to do our intercepts for each of these, so our intercepts here would be 0, 9, 0, 1, 0, 0, and then 0, 4, no, 4, 0, sorry, the -4, 0. Over here we would have 0, 2, 0, -2, 0, 0, and then 4, 0, and 8, 0. Okay, so moving on. Number 11. Once again, these are different numbers, so this is going to be another limation. A is 3, B is 5. So A plus B was going to give us 8. B minus A is going to give us 2. Because it's a sign and this is negative, it's going to be opening down. We have a loop length of 2. And an overall length of 8. A is 3, so our intercepts are going to be 3. Our loop. Now number 12 is a little different. It's still a limation, but in this problem A is 4, B is 2. So A plus B is going to give us 6, but this time B minus A is going to give us -2. So far we've never had a negative, right? Because 2 minus 4 is going to give us -2. So essentially what's happening here is we have no loop. So instead of being at 0, 0 and opening into a loop, it goes the opposite way. So this is cosine. And it's positive, so it's going to be opening to the right. So we're going to go out 6 for our total length to the right, but instead of having a loop at 2, it actually gets pushed out in the opposite direction, 2. Our A is 4, which means we're going to have intercepts at 4 going up and down. And it looks something like this. It's not quite a circle, it's almost like a circle that got flattened out here, and it doesn't have a loop. It's still this same type of graph, name-wise, but there is no loop because B was smaller than A. Okay. Okay, on this page, what I want us to focus on is the roses. So a rose looks like one like number 3. This would be a rose. When we have roses, if our number in front of the theta is odd, that tells us how many petals there are. So there are going to be 9 petals here because this number is odd. Now each petal is going to have a length of this number, which is 7. Okay. Number 6 is another example of a rose. So in this problem we have a rose. This is even this time, so when we have even, we have double the amount. So if this is a 4, that means we have 8 petals with a length of 7. So then number 9, because 5 is odd, we would have 5 petals with a length of 8.